Welcome to the educational component for AATCC student competitions. The information in this presentation will help you prepare your entry for the 2019 design or merchandising competition.
Think about your favorite textile items. Whether it's clothing, curtains, or car interiors, the best products not only look good but function well. Testing is an important tool for ensuring both. Standardized testing means using established test methods that others can also use to verify and compare results. You probably took a standardized test as part of your college application process. You may not have liked taking the test, but think about it from the admissions officer's perspective. It's hard to compare scores for final exams prepared and administered by thousands of different teachers. It's a lot easier to compare scores on a standardized test where everyone answers the same questions, following the same rules. Of course, a great score on one test is not enough to ensure you will succeed in school, and it's not enough to guarantee a fabric will work in your garment. Whether you're an admissions officer, a designer, or a buyer, you need to consider a variety of factors in making your final selection, including standardized test results. Choosing the right tests is important too. A perfect score on a law test won't get you into med school, and a fabric with excellent water repellency probably won't make a very absorbent towel. Testing helps ensure your product will meet customer expectations, avoiding returns and encouraging repeat sales. The stakes are even higher when you add functional or performance properties. Truth in advertising laws say that any claims must be truthful, not misleading, and when appropriate, backed by scientific evidence. Failure to properly support your claims can result in fines and product recalls. The requirements of a casual t-shirt are pretty simple. It should maintain its size and color in normal use. It should stretch enough to get it on comfortably, but recover or return to its original size so it's not a droopy mess. There are standard test methods to evaluate all of these properties.
Adding performance properties makes things more complicated but can set your product apart from the competition. You might enhance that basic t-shirt to protect the wearer from sunburn. You might use a fabric that quickly wicks perspiration away from the skin. You might even add reflective elements to make the wearer more visible to drivers while running at night. Standardized testing provides the scientific evidence you need to support these claims.
The theme of this year's AATCC C2C design and merchandising competitions is splashing around. You will design or merchandise fashionable, functional apparel for use in the rain. Your challenge is to determine the specific needs of your garment or garments. What activities will the wearer be doing while wearing your designs? Will they be the primary protection from the rain or just a backup layer? Will they be used in a light shower or a storm? What other performance properties will your garments provide?
This tutorial will provide an overview of some of the most common test methods used for evaluating water repellency and resistance of textiles, so you can choose the ones best suited to your designs.
If you need additional information, AATCC offers a variety of resources online, in publications, through conferences and educational events, and of course through networking and exchange with fellow members. A common language is an important first step in meaningful standardized testing. There are a few important terms you should understand for discussing rainwear. A good place to start is with the term wetting. The glossary of AATCC standard terminology defines wetting as the time required for a drop of water to lose its light reflection characteristics, when the drop goes from sitting on the surface of the fabric to soaking in. Water repellency is the characteristic of a fiber, yarn, or fabric to resist wetting. This means it keeps water from soaking into the fabric. The water drops should bead up and even roll off the surface. Water resistance is the characteristic to resist wetting and penetration. A water-resistant fabric keeps water from passing through, even if its surface gets wet. There is no technical definition of waterproof in the AATCC glossary. Waterproof suggests that a fabric is completely impervious to water, but no fabric can withstand water forever. Some people have suggested qualifying the term by saying a fabric is waterproof at a certain pressure or for a certain time. A safer option is to avoid this term completely. The most common test method for evaluating water repellency is AATCC Test Method 22, Water Repellency Spray Test. Water is sprayed on the surface of the fabric. Because it's a standard test method, the type, quantity, and temperature of the water are specified. The nozzle design, spray distance, fabric angle, and other variables are also defined to ensure repeatable and reproducible results. Loose drops are knocked off, and the wetting pattern is compared to a photographic scale, 100 for no wetting, 0 for complete wetting. Look at a few sections from Test Method 22. Not surprisingly, they talk a lot about finishes, chemical treatments applied on the surface. Remember that repellency is all about what happens on the surface of the fabric. AATCC Test Method 70, Water Repellency Tumble Jar Dynamic Absorption Test, includes similar language. Of course, water repellency and water resistance are closely related. Some tests look at both, and often a water repellent finish is the first line of defense for a water-resistant fabric. If the water rolls off the surface, it can't soak through. In the tumble jar test, fabric specimens are, you guessed it, tumbled in a jar with water. The specimens are weighed before and after testing to determine how much water is absorbed. There are several commonly used AATCC test methods for water resistance. AATCC Test Method 42, Water Resistance Impact Penetration Test, looks like the big brother to the spray test. With more water and a greater distance traveled, the impact penetration test can get past the surface treatment to provide an understanding of how well the fabric prevents water from passing through.
In the impact penetration test, a piece of blotter paper is secured completely behind the fabric specimen. The assembly is then mounted on the test apparatus. Next, a weight is clipped at the end of the specimen to hold it taut. Water is poured through the funnel just as in the spray test. Note the increased height and different nozzle. The impact penetration test also uses twice as much water as the spray test. The amount of water penetration is measured by weighing the blotter paper before and after the test.
AATCC Test Method 35, Water Resistance Rain Test, is a standardized test that most closely mimics what rainwear faces in the real world. It's not by accident that it's called the rain test. At first glance, it doesn't look like rain at all. The water hits the fabric specimen horizontally rather than from above. However, studies have shown that the results of this test are closely aligned with those in a rain room or a real rainstorm. This test also offers several options to help you more fully characterize a fabric in addition to assigning a pass-fail rating. As with the impact penetration test, water resistance of a specimen is measured by the amount of water absorbed by the blotter paper secured behind the specimen during the test. Unlike the rain test, AATCC Test Method 127, Water Resistance Hydrostatic Pressure Test, is not a direct representation of what you are likely to experience while walking in the rain. Instead, it provides an extreme, accelerated challenge to allow comparison of highly water-resistant fabrics. The hydrostatic pressure test applies increasing water pressure directly against the fabric. The test stops when 3 drops of water pass through the fabric. Results are reported as the height of the water column at which the test is stopped. A relatively new test, AATCC Test Method 208, Water Resistance Hydrostatic Pressure Test using a restraint, is performed with a plastic restraint to keep the fabric from stretching. You don't normally wear a rigid plastic plate with your rainwear, but using one for the test allows you to apply even higher pressure and perhaps identify differences between fabrics that all perform well at lower pressures. Hopefully your customer will never encounter rain at 20,000 millimeters of pressure.
You can download a summary of AATCC water repellency and resistance test methods from the Concept to Consumer competition page.
For complete purpose, scope, and principle of these and other AATCC test methods, visit www.aatcc.org/test/methods. For the complete methods, check your classroom or library for the 2018 AATCC Technical Manual.